So in the subject of mathematics, you have many times seen many statements. So let's see what are these statements. They are conditional statements. So let's see what are conditional statements. The statements which can be written in the if-then form are called conditional statements. Means these are such statements, they have if and then. Okay, then that statements are called as conditional statements. The part of the statement following if is called the antecedent, and the part following then is called the consequent. These statements have two parts, the part having word if and the part having word then. The part which has if is called as antecedent and the part which has then is called consequent. So let's see example for understanding this in a better way. So here one example is given. The diagonals of a rhombus are perpendicular bisectors of each other. So this statement you have heard or you have learned in previous standards also. So you know if a rhombus has diagonals, then their diagonals are perpendicular bisector of each other. So this statement can be written in a conditional form as if the given quadrilateral is a rhombus, then its diagonals are perpendicular bisectors of each other. So we have seen that all the quadrilateral are not rhombus. Okay, there are many quadrilaterals. If we have to write this statement in a conditional form, then how we will write? If a given quadrilateral is a rhombus, if a quadrilateral is rhombus, okay, then only the diagonals are perpendicular to each other, perpendicular bisector of each other. So in this way we will write the statement in a conditional form. If the given quadrilateral is a rhombus, then its diagonals are perpendicular bisector of each other. So here what is antecedent? The part which is consisting of if. And what is consequent? The part which has then. So now we have seen the example of conditional statements. It is nothing but a statement having if and then. Okay, so what is converse then? In converse, there is nothing but we have to interchange the statements of consequent and antecedent. Then it will become a converse statement. Okay, so it is not important or it is not compulsory that if the conditional statement is true, then the converse of that statement will also be true. The example that we have seen was if a quadrilateral is a rhombus, then its diagonals are perpendicular bisector of each other. So let's see the converse of the statement. If the diagonals of a quadrilateral are perpendicular bisector of each other, then it is a rhombus. So yeah, it is true. Because if we have one quadrilateral and the diagonals of that quadrilateral is a perpendicular bisector of each other, then we will understand that this given quadrilateral is nothing but a rhombus. Okay, so therefore the converse of this conditional statement is also true. Okay, if we have given that a quadrilateral is rhombus, then we will understand that perpendicular bisector, the diagonal is a perpendicular bisector of each other. And if we are given that a quadrilateral has diagonals perpendicular bisector of each other, then we will understand that given quadrilateral is a rhombus. So here the conditional statement and converse both are true. Let's see one more example. Here conditional statement is if a number is a prime number, then it is even or odd. So we know that a prime number can be even or it can be an odd number. Okay, so that is what here written. If a number is a prime number, then it is even or odd. And if we will see the converse of same statement, what we will get, if a number is even or odd, then it is a prime number. But this is not acceptable. Why? Because every even and odd number is a prime number. No, that is wrong. You know, it can also be a composite number. So therefore the converse of the statement is completely false. It is completely wrong. But the conditional statement is true. A prime number can be even or odd. But it is not possible that all even and odd numbers are prime numbers. So therefore in this example, converse is false but conditional statement is completely true. So I hope you have understood what are conditional statement and converse of this statement. So let's see some proof. As we have learned so much about angles, triangles, quadrilaterals, we have seen so many statements, but we have never proved anything anywhere. We just accept whatever is given, whatever it is written as it is. But now in this standard we will learn the geometry in a new way. So in the 3rd century before Christian era, there was Euclid, the mathematician, Greek mathematician, very great mathematician. So he gathered knowledge about geometry and he gave some geometrical statements and which were accepted by all, means all the people after him accepted all his statements. So those statements are called as postulates. He also showed that with the help of postulates we can prove many logical properties. So these properties that we can prove logically, they are called as theorems. In the upcoming standards and chapters, you'll come to know more about theorems, postulates, and you will also understand how much helpful they are for our geometry. So here are some postulates which were given by Euclid himself. So the very first one is there are infinite lines passing through a point. So this we have seen in previous standards also. We have learned about that if there is one point, then we can draw many lines passing through that point. Okay, so this was a postulate which was given by Euclid. The second one is there is one and only one line passing through 2 points. So this also we know, if there are 2 points, then we can only draw a single line which will pass from that both of those points. Okay, next one is a circle of given radius can be drawn taking any point as its center. So if we know the radius of a circle, then we can take any point as its center. Next one, fourth one is all right angles are congruent with each other. All the angles having 90 degree, they are called as right angle, and as all right angles measure equal, therefore they will be congruent to each other. Next one, if two interior angles formed on one side of a transversal of two lines add up to less than two right angles, then the lines produced in that direction intersect each other. In the diagram, you can clearly see that there are two lines, line L and M, and one transversal, that is line N. And here this transversal intersect both the lines, and the interior angles formed here are angle A and angle B. But both of them are less than 90 degree. Both of them are less than 90 degree, and the addition of both of them will be less than 180. So if such a condition occurs in a diagram, then you can clearly understand that both the lines, the line L and M, they are going to intersect each other at a point somewhere. Okay, so that is what written in this postulate, that is here the side where two interior angles are less than the addition of two right angles, at that side only the two lines going to intersect. Okay, this was the postulate given by Euclid. Many of these we have seen previously also, and we have never proved this anywhere, so therefore they are called as postulates. And if we prove them, then that proof with a logic is called as theorem, and the logical argument made to prove a theorem is called its proof. The steps which we follow to prove our theorem, our postulate, that steps or that argument is called as proof. Okay, let's learn more about theorem and proof. When we are going to prove that a conditional statement is true, its antecedent is called given part and the consequent is called the part to be proved. So if we are proving a given conditional statement, then that is called as theorem. Okay, and every conditional statement has two parts. So the part which is antecedent, if we are proving that conditional statement, then that part is called as given part, and the part consequent is called as part to be proved. Okay, so now we will see the proof of the theorem. First of all, there are two types of proof, direct proof and indirect proof. So let's see. Here one theorem is given: the opposite angles formed by two intersecting lines are of equal measure. So in this statement, the given part is line AB and line CD intersect at point O such that A dash O dash B and C dash O dash D. That means these three and the other 3 points are collinear. Here it is shown the betweenness. So it is given that two lines are intersecting each other. Now what we have to prove is angle AOC is equals to angle BOD and angle BOC is equals to angle AOD. If we will prove this, then we can also prove the theorem, that is the opposite angles formed by two intersecting lines are of equal measure. So line AB and CD, and this are the opposite angles. Okay, line angle AOC and angle BOD are opposite to each other. So that's why we have to prove these two angles to be equal. So let's see the proof. Angle AOC plus angle BOC is equals to 180 degree. Here you can see in the diagram the angle AOC and angle BOC. If we add both of them, they will form 180 degree. Why? Because they are the angles forming a linear pair. What is linear pair? The two angles, the two adjacent angle, they form 180 degree. Okay, they form a straight angle. Such is called as linear pair, such angles. So here that's why angle AOC plus angle BOC is 180 degree. And again angle BOC plus angle BOD. If we add both of these also, then they will form 180 degree. Why? Because they are also forming a linear pair. So therefore, in this two statement, that is angle AOC and angle BOC, both of addition of both is equals to 180 degree, and in the second statement, angle BOC plus angle BOD, they were also equals to 180 degree. So if both of these angles addition is equals to 180 degree, that means both of them are also equal to each other. Therefore, from statement 1 and 2, we will write angle AOC plus angle BOC is equals to angle BOC plus angle BOD. So here there are two BOC, angle BOC is present in both the sides. Then if we will shift any one to other side, it will become minus angle BOC. So plus angle BOC and minus angle BOC both will cancel each other, and in next line we will only get angle AOC is equals to angle BOD by eliminating angle BOC. So we proved finally that angle AOC is equals to angle BOD. That means if two lines are intersecting each other, their opposite angles are equal in measure. That is why we got angle AOC is equals to angle BOD. They are opposite to each other. So similarly, we will also prove angle BOC and angle AOD. So this is how a theorem is proved, and this is our proof of that theorem, and that's why this theorem is completely correct. This postulate is completely correct because we have proved it, and we proved it direct, that is without taking the help of any assumptions or other. So that's why this type of proof is called as direct proof. Let's see one example of indirect proof. In such proof, we take an assumption. Okay, what is given and what we have to prove, we take something opposite to it, and we prove ourselves wrong. And if we proved ourselves wrong, then we accept that the given to be proved is correct, because what we have assumed is incorrect and it was opposite to the real one. Then if we prove ourselves wrong, then we accept the given one. Okay, so let's see, you'll understand with the help of example. Here a statement is a prime number greater than 2 is odd. Okay, so if we have to write it in a form of conditional statement, we will write it like, if P is a prime number greater than 2, then it is a odd. Okay, so if P is a prime number which is greater than 2, then it should always be odd number. This is what we have to prove. So what is given? Let's see first that P is a prime number greater than 2. This is given that P can be any number, but it should be greater than 2. That is 1 and P are the only divisors of P. And it is a prime number. That prime number means it is divisible by only 1 and itself. That means like 2. 2 is divisible by 1 and 2. And it comes in none other table. Okay, it is divisible by no other number. Only 1 and itself. Similarly 3, 5, these are numbers. They are only divisible by 1 and itself, and no other number can divide them, can simplify them. Such numbers are prime number. So if it is given that P is a prime number and it is greater than 2, which means that the factors of P can only be 1 and P itself. Okay, so what we have to prove is that P is an odd number. It is given that P is a prime number and it is greater than 2. But what we have to prove is that it is only an odd number. No even number can be a prime number and greater than 2. So let's see, can we prove it? So let's see the proof. Let us suppose that P is not an odd number. So as I said, we are using indirect proof. Then what we will take an assumption. So what we are assuming here, that P is not an odd number. It is given that it is odd number. We have to prove that it is odd number. But we are taking something opposite to our 2 proof. And the opposite to odd number is that it is not an odd number. So that's what we have taken here. So P is an even number. If it is not an odd number, then it is an even number that we are assuming here. Therefore, a divisor of P is 2. As it is an even number, so it is divisible by 2. Therefore, a divisor of P is 2. But it is given that P is a prime number greater than 2. Therefore, 1 and P are the only divisors of P. So it is given that P is a prime number. That means it should not have any factor other than 1 and itself. But as we are assuming P as an even number, so according to us, one factor that we are getting is 2, and which is not possible because P is a prime number. How it can be divisible by 2? So this is a contradictory. What is given and what we are getting, both are completely opposite to each other. So therefore, if we'll see the statement 1, that P has a divisor 2, and the statement 2, that 1 and P are the only divisors of P, they are not satisfactory. They are contradictory. So therefore, statement 1 and 2 are contradictory. Therefore, the assumption that P is not odd is false. This proves that the prime number greater than 2 is odd. So our assumption was completely wrong, completely false. What we have to prove was it is odd. But what we have assumed that not, it is even. But it cannot be even, and if it is not even, then a number can only be odd number. So that's why now it is proved that a prime number greater than 2 is odd. Because if it is not even, then it can only be an odd number. This is how indirect proof works, with the help of an assumption. We are taking wrong assumption and we have to prove ourselves wrong to prove the statement to be true. This is indirect proof. I hope you have understood what are direct and indirect proof. Let's start with practice set 1.3. Question number 1 says, write the following statements in if-then form. So here some statements are given and we have to convert them into conditional statement. First one says the opposite angles of a parallelogram are congruent. This is a statement and we have to make it a conditional statement. That means we have to use if and then here. So how we will use? The answer is, if a quadrilateral is a parallelogram, then its opposite angles are congruent. Second one, the diagonals of a rectangle are congruent. Now how we will write it in a conditional form? If a quadrilateral is a rectangle, then its diagonals are congruent. This is our solution. Third one, in an isosceles triangle, the segment joining the vertex and the midpoint of the base is perpendicular to the base. Now we have to convert this into if-then form. If a triangle is an isosceles triangle, then segment joining vertex and midpoint of the base is perpendicular to the base. Question number 2. Write converse of the following statements. So here some statements are given. We have to find the converse of the statement. That means we have to exchange the antecedent and consequent. First one says the alternate angles formed by two parallel lines and their transversal are congruent. Let's see the solution of this. That is, the converse of the above statement is, if alternate angles formed by two lines and its transversal are congruent, then the lines are parallel. Easy. Second one, if a pair of the interior angles made by a transversal of two lines are supplementary, then the lines are parallel. The solution can be, converse of the above statement is, if two parallel lines are intersected by a transversal, then interior angles so formed are supplementary. Third one, the diagonals of a rectangle are congruent. Solution, if the diagonals of a quadrilateral are congruent, then the quadrilateral is rectangle. This we have also seen in rhombus. So all of them were very easy. Question number 1 and question number 2 was very easy. Practice at 1.3 is completely very easy. I hope you have understood each and every concept from this chapter. Keep practicing more and more. And if you want to ask something, you can ask below there.